This video is brought to you by Sporlan, quality, integrity, and tradition. All right, I am back here today. We had originally come out here, I had another service technician out here, and the dining room AC wasn't working. And he came up onto the roof, it had no power. I was not the diagnosing tech. And he turned off the disconnect switch, went downstairs, found that the breaker was tripped down at the panel. It's key that he turned off the disconnect switch, because you never want to reset a breaker if you can and energize the load from downstairs. So you turn it off up here, go downstairs, reset it, and then come up here, look into it before you turn it back on. You know, you always want to check everything to ground and all that good stuff. So with that being said, when he went downstairs to reset the breaker wouldn't reset, the breaker was bad. So we had them call an electrician. Now, that was a process because it's like 3 weeks ago. I don't know, whatever. But they just got the breaker replaced yesterday. So supposedly we have three-phase power energized up here now, but I still have it off, or we still have it off at the disconnect switch right here. So we need to figure out what caused the breaker to trip. Some context: we were having an electrical storm that day. We had thunderstorms and everything. We had a couple restaurants in this area that just had nuisance electrical problems. Recently just made a video about an exhaust fan that was tripped because of a 24-volt fuse. That was that same day that this problem surfaced too. So it could just be a nuisance problem from that weird electrical storm we had going on, or we could have something else bigger. So we need to look into that again before we energize power. So the first thing we're going to do is check to see if power is properly restored, and then we're going to just go through and check all the components. If we don't find anything wrong, then we'll energize the unit and troubleshoot it from there. All right, so I'm going to check this guy. Line 1 to 2, 201. 1 to 3, 201. 2 to 3, 200, right around 201. So we have proper power coming up to the unit. Now we need to check the other side to make sure that there's nothing that could have caused the breaker to trip. All right, so now that we have proper voltage at the breaker, we're checking resistance to ground, and then we're also doing a mega ohm test. I'm just curious, so I'm just writing down the readings of the mega ohm test just to see where we're at. So each winding to ground, I'm at 550 mega ohms. We're gonna test the other one too, just to make sure. Now, this is just a baseline because this unit's been off for a long time. Keep in mind that when you're taking an insulation test or mega ohm reading, if the compressor's been running, the temperature of the ambient, everything affects the insulation resistance or the reading. Okay, so if you've seen one compressor running and then one compressor's been down for a long time, you're going to see a big discrepancy between the two. So keep that in mind. But we just tested this one. Insulation testing is new to me. Okay, I've read about it a lot. I'm more or less doing this just out of curiosity, but I will tell you that you don't want to just assume, unless you have a crazy low number, that you have a bad compressor because of an insulation test reading. You always want to look further, because moisture in the system, different things like that, temperature, all that can affect the reading. Okay, so keep that in mind. But we're just going through everything. We're going to check all the motors, spin them, all that good stuff. I'm just more concerned about the compressors right now, so we're going to check the other one. All right, I haven't tested this one yet, and I don't think this is the cause of the tripped breaker, but look closely at that wire right there, and it's definitely had some overheating going on. The other ones don't look as bad at the connection point, but that one's definitely had something going on there. So we're going to look into repairing that if I can. Yeah, I don't know if I have a terminal kit for this guy. We'll have to see. But you definitely had some overheating, which can... Oh yeah, look at that's why it's overheating. Look at how loose that is. You've got a loose terminal. It's super loose. The other ones, they don't come off. This one right here, boom. That would cause a breaker to trip. Definitely. So that could be part of the reason. We'll fix that and then keep going. All right, so different probes apply to different situations. On the other one, I was using just the normal needle probe. On this one, it's going to be easier, because trying to hold the probe on there when you're doing the insulation test isn't very accurate. So you get a consistent reading this way. We've checked 2 of the terminals. They're 550 mega ohms, same as the other one. We're going to check the last one right now. So I like how on this is the Fluke 1587. So on this one, it saves your last reading. So you just hold down insulation test. It gives it a second, and then it'll give you your reading. It tells you the voltage at which it's testing, 527, and we're getting 550. So we're getting an even 550 mega ohms on on both compressors, each winding. So that looks good to me. Don't see any issues there. Now the cool thing, or the important thing to understand again about insulation tests, is you really want to pay attention to the data and save everything. So we have the voltage at which we're testing at, we have the resistance or the insulation test reading, and then we also need to write the ambient temperature outside, and note that the compressors have both been off for an extended period of time. You want to write that down, because you can have if we let these things run for an hour, we'll get a different reading on them, because once everything starts warming up, the oil starts moving around, you'll get a different reading, like I said. So all right, I had a lead repair kit. Comes with new flag terminals and splice connectors with heat shrink butt connectors. Keep a lighter. I don't have a lighter in my van, so I had to use my MAP gas torch, my heat producing device. But you know, a little bit of burning, that's fine. It's not really hurting too much. So we'll tape that up. I would love to get an actual flag tool for doing the flag connections, but I have yet to been able to see one at any of my local supply houses or anything. I'm the kind of person that likes to hold things. I guess I'm probably gonna have to order one from the internet. It's just kind of weird not being able to see something before you buy it. But if any of you guys have ideas or have a flag connector, that crimper tool that you like, let me know, because I'm always looking for one. If you guys don't already know, the standard crimping tool isn't the right one to do these flag terminals. It's actually a different type of a crimp. So, but I'm going to tape these up with electrical tape, get this put back in, and then we're going to further or finish diagnosing the unit. You want to kind of, you know, just investigate the wiring. It's not perfect, but it's kind of hard to predict everything. That's what testing for continuity and stuff will do. But I'm not seeing any rub outs that I can tell. The unit's definitely old. The contactors are not in the greatest of shape. It's going to be hard on camera to show this, but there's quite a bit of pitting going on inside the contact points. So we're probably going to go ahead and replace some contactors on these guys too. This one looks like it's been overheating. You see how one side is still brass and one side is kind of a dark red color. So that's potentially problematic. So this is the kind of stuff we want to look for. We're just looking for anything that could have tripped the breaker. Definitely be checking the capacitors back there in the corner too. All right, I want to change those contactors, but I want to make sure the compressors run, because just because electrically they looked okay, they could be locked up too. Again, we don't know what caused this breaker to trip. So before we replace the contactors, we're going to test continuity to ground on the rest of the unit really quick, just real quick. And then we're gonna bump start the compressors, make sure they run, blower motor and condenser fan motors. And then once we know everything runs, then we'll dive in deeper and start changing contactors and stuff. But I hate to throw a bunch of parts at it if there's gonna be, locked up compressors or something, right? You don't wanna waste money. So we've got this guy hooked up to ground. We're just gonna make sure we get tone. We get tone and we get resistance at the same time. So we're testing the load on every contactor to ground. Nothing. We'll check the line side. We've got no resistance to ground whatsoever. Okay, we'll check the main over here. Nothing. Condenser fan motor contactor. Nothing. All right, it's that time. So we're gonna go ahead and fire on the disconnect. Power's on. We're gonna come over here. We're gonna put the unit into test mode. Right here. Give it a second. Their test mode, if you want to know how it works, there's a little thing right here. Pull that off. There goes the indoor blower motor. Should be economizer, if I remember right, is the next function. You leave it on for a couple seconds and take it off. Then it should be a compressor. Come on, baby. I'm supposed to like put it on for 2 seconds, take it off. I'm missing something here. I'm probably messing it up. Should show, it's usually an LED light to indicate we're in test mode. There goes one. We know one compressor works. Let's go ahead and turn on the next one. That's circuit 1. Circuit 2 should be next. Condenser fan motors are working. Okay, CFMs are running. So we're just waiting for our second stage compressor. There it goes. Okay, so everything works at this point. Now, we need to go ahead and put refrigerant gauges on the unit, fully diagnose everything, and I'm gonna go ahead and change those contactors. But I'm gonna change the contactors first, now that we know both compressors work and the blower motor and everything runs. Okay, one capacitor's reading 24.84 and it's a 25, so that's fine. I need to disconnect and do the other one real quick. The other capacitor is right at the threshold of being too low. 23.5 would be the 6%. The capacitor says plus or minus 6% and it's a 25 microfarad capacitor. So we're right at, so we're allowed to run 23.5, we're right at 23.8. I'm probably gonna go ahead and change the capacitors too, just to be safe. All right, I got the capacitors changed. I went ahead and changed the condenser fan motor relay too. Working on the contactors, and these lugs wouldn't come loose. They were really difficult. Get a screwdriver that you don't like. I have my fancy insulated one. I didn't want to break that one, so I grabbed one of these and put heavy pressure on it, and then used my Knipex pliers right there while I was pushing really hard, and I was able to very carefully break them free. But again, it was a screwdriver that I didn't care if it got jacked up or something. So just a little bit at a time. Got the contactors all changed out, nice and neat. If you look up into here, you can see what we were dealing with. Look at how bad and pitted out those were. Look at the points. Look in there. And then it's hard to see, but it's really jacked up inside too. And the same thing on this one. Really messed up in there. So whenever, and these are all original contactors too, I can tell. So in that situation, once I see one that's really bad, you see two that's really bad, it's pretty safe to say the others are too, and that proves my point. And it's pretty safe to say this one's probably gonna have some corrosion inside too, or some pitting, but this one's sealed, so it's not gonna be as bad, but we're changing it out of precaution too. Yeah, we're gonna open this up, check the belt, and then we gotta probe up on it and turn the unit on and watch the pressures and see how it's functioning. Came in here to the belt. It's looking pretty good. I tightened it up just a little bit. This one, you just loosen the inside nut, tighten on the idler pulley on the outside nut, and it grabs these little gear thing with a little sprocket, grabs those, tightens it, and then you tighten down this nut. So this guy's good. Got a spare belt in here. Looking good. All right, we're getting ready to probe up. Using the job link probes, we got a discharge clamp, discharge and suction. I like this big, the JL3LC large pipe clamp, because it fits around that, what is that, like 1 3/8 I think, suction. So that's nice having that. I just keep a variety of clamps in here. That's my normal suction clamp, and then I got a couple other big ones and more pressure probes and stuff in here. And then we have a liquid line clamp. So this is a fixed orifice metering device. It has the actuator style header. So we're going to check the charge, and you use target superheat on this one. That's based off of indoor conditions, outdoor conditions, and it's going to fluctuate. It's not just a set number all the time. Depending on the load, it's going to change. So we're going to go ahead and turn this guy on. When we're diagnosing too, you want both stages running. In a perfect world, you want the evaporator coil completely loaded from top to bottom with moisture, so we want to let it run for 5-10 minutes, and then we'll see where everything's going. All right, I'm using the app Measure Quick with the field piece job link probes. This is the first stage compressor. We're looking good. Evaporator pressure or temperature looks good. Condensing temperature looks good. We're right within what Measure Quick says we should be. Superheat's pretty much on point. It says the target is 12 degrees. We're reading about 14 right now. It's been running for about 10 minutes. Let's scroll on over. I bet you we're gonna see a little bit low airflow. Approach temperature looks good. Airflow's not too bad. Temperature split's right on point. Yeah, first stage is looking good. We're gonna go ahead and jump on over to second stage and have a look. The reason why I thought maybe we were gonna see an airflow issue is the evaporator's a little bit dirty. We're gonna probably have to schedule a thorough cleaning on this guy. It's not horrible, but it's got a bunch of dust on it. And I'd also like to split this condenser because this is a double road condenser. It's not something I can do today, but I'm pretty confident it's gonna be dirty inside too. But obviously not bad enough to where it's affecting our temperatures or anything, or our pressures, so not too bad. But all right, we're gonna jump onto the second stage. Second stage, you know, a little bit high on the pressures, but it's still on the money where it's supposed to be. Superheat, yeah, just a little bit on the high side, but I'm not scared of anything I'm seeing here. This is looking pretty darn good. So pressures look fine, don't see any issues with that. The next thing we're gonna do is just test current on all the motors, the compressor and the indoor blower motor. We'll test that real quick. And yeah, that's pretty much it. So let's get on the testing current right now. So RLA on the first stage is 33 amps. We're slowly climbing, but I've also got the door open, so that's not bad. Second compressor, I believe, is in the 20s. I'll look at that one real quick. Let's see, second compressor is allowed to run 20.7, and then indoor blower motor, I think it has the 5 horsepower, is allowed to run 16.7. So we're under the 20 amps. Let's see if I can get on this. Oh yeah, we're good on the indoor blower motor too. So, oh, condenser fan motors, last one. Condenser fan motor right here, 3.8, and then right here, 3.3. So condenser fan motors, 3.8, 3.3. Let's see what we're allowed to run. 5.5. So everything's testing under current like it should be. We're good to go. So we fixed the problems that we think could have potentially caused the breaker to trip if it wasn't caused by the electrical storm that they had, where we had, you know, weird power issues. So we replaced some contactors, some capacitors. We fixed a burnt or a loose wire on the compressor terminal that very well, all of those things could have led to a breaker tripping. Other than that, that's it, guys. We're gonna wrap this one up. This is just one where I don't just come in here and reset a breaker. It's big picture diagnoses, right? We look at everything, we do our best. Now, I'm not gonna give them a 100% guarantee that everything's fixed, but I'm gonna give them a guarantee that I did my best. I checked everything that I could. From this point forward, we're just gonna have to wait and see if we have any other issues. So it's so important to look at the big picture, guys. I know, as corny as it sounds, you don't just want to walk up. I mean, this could have been easy. I could have just walked up. I could have just flipped a breaker. It probably would have ran, okay? But we take the time to go through the system, to do our best, to try to figure out why the potential short is, you know, we don't know exactly what happened, but why the potential short might have tripped a breaker if that's what caused it, okay? Sometimes you have to take an educated guess, but we do our best to find the problem before we try to reset the breaker, okay? I've told it in the past, you know, it wasn't my fault, but there's things I could have done to have changed it before. I walked up on a system that had blown fuses. I replaced the fuses. I turned the disconnect switch on. And I think this was a long time ago, so I think I did it once or twice. But regardless, I turned the disconnect switch on, and then all of a sudden, the main for the building blew, okay? Or the main for the entire sub panel that ran half the building blew. And when it blew, okay, because there was still a direct short in the system, I did not check, and this was in the past, I did not check for direct shorts to ground before I turned the disconnect switch on. Then it tripped the main, and when the main tripped, the main broke. Something internally catastrophic happened within the main breaker, and they couldn't reset it. And this was at a fancy golf course. It was a funky 480 volt breaker, and long story short, the electrician couldn't replace it until the following Monday, and it was like a Friday afternoon, okay? So that golf course had to go without half, you know, whatever that panel controlled, air conditioning systems, refrigeration systems, you know, for the weekend, basically. And while it wasn't my fault that the main broke when it tripped, there's things I could have done to have prevented that situation. So I learned something from that point, and that was probably 15 years ago. You know, anytime I approach a tripped breaker, you always de-energize the load, then try to reset the breaker, then go back and try to figure out what potentially could have caused that breaker to trip before you reset the system, okay? Because we're trying to prevent those trips to the circuit breaker. You know, because every time something happens, let's just say that you had a direct short in a compressor. Well, there's always the potential that you have a direct short, but it didn't burn the refrigerant, it didn't burn the oil. But if you keep resetting the breaker, that electrical short can cause issues with the oil and the refrigerant. So you can save the refrigerant. You can, you know, potentially save yourselves from having to go through a nasty burnout procedure to clean out a system. It's just so important. And for safety reasons too, you always want to go through the system and do your best to try to find things before you reset the breaker. And then you want to do things systematically and think logically while you're doing it. So in this situation, I went through the system, I found a loose wire in the compressor. Okay, I didn't stop there. I went ahead and repaired that. I found that the contactors were pitted out really bad. Okay, I moved on. But before I replaced all those components, I went ahead and energized the system after I checked to make sure there was no other direct shorts. That way, I didn't waste the customer's money going in and replacing all the contactors to find out we had 2 locked up compressors. You get where I'm going there? So it's taking the time, slowing down, and thinking about the process to try to give the customer the best bang for their buck. And in the process of doing that, I'm being very thorough going through their system, again, giving them the best bang for their buck. And at the same time, I'm covering my own butt in my diagnoses, because I told the customer I did everything that I could, you know, make sure everything was good. Then I turned the system on, you know. So it's always about taking the time, slowing down, thinking about the problem and addressing it accordingly. Okay, I can't stress that enough. You know, like I said, there's a very good potential that I would have just reset the breaker and it would have ran fine, but maybe it would have tripped again. And who knows, maybe even the problems that were there that I fixed might not have even been the issue that caused the breaker to trip, but I did my best to try to prevent any future problems, okay? Then we went through the system, checked out the refrigeration circuit, made sure they were working fine. They were good, okay? Of course, I'm recommending to the customer that we go ahead and come back, split the condenser, clean it, clean the evaporator, and then we'll address the refrigerant pressures even more in depth once we do that. But I wasn't too concerned with anything that I was seeing, okay? So it's always important that we take that time and be thorough. I really, as usual, I know I say the same stuff all the time, but I appreciate you guys so much. It's so humbling to see the support from you guys. Like I said in the beginning, the small, medium hats are back in stock. I was out of stock with them for about a week or so. It's taken a while to get them, but we're back in stock. If you guys were looking for that size, go check out the website, hvacrvideos.com. Other ways you guys can support the channel, say it all the time. There's going to be links in the show notes to everything I'm going to mention. You can support the channel via PayPal. You can support the channel via Patreon memberships, via YouTube channel memberships. If you're interested in purchasing any tools, TrueTechTools.com. I have an offer code Big Picture. You can save 8% as of today. It is September 25th of 2021. It may change tomorrow, but today it's an 8% discount. If you shoot me an email with what you're going to purchase from TrueTech Tools, I can generate an affiliate link that will get me a little bit of an extra commission, but you still get to save your 8%. The easiest way, though, like I say all the time, is just simply watch the videos from beginning to end. Let YouTube handle all that stuff, okay? I appreciate you guys so much, and if I can kindly ask you guys, just simply slow down. Remember, just because someone's being a jerk to you doesn't mean you need to be a jerk to them. Maybe something's going on in your life. It doesn't justify their actions that they're being a jerk for, but sometimes we just need kindness, okay? And even though someone's being rude to you, just be polite to them back, okay? Just bite your tongue, you know, random acts of kindness, whatever you want to do. Just, we need to be more kind, guys. There's too much craziness. There's too much anger, confusion, fear going on right now. And some of those things we can't control, but the one thing we can control is how we go about our daily lives and how we, express ourselves to other people. Right? So just simply be kind, hold a door open for someone, buy a coffee for someone, help someone out, answer a phone call from one of your fellow service technicians. I know it's Saturday, I know you're not working, but maybe he just needed a helping hand. Maybe he just needed you to walk him through something that he doesn't quite understand. And it's something as simple as picking up the phone. You know, another thing that I don't think I talk about enough is, remember, everybody's going through crazy stuff in their head. Everybody has mental issues, mental health stuff. I deal with it myself. It's a struggle I'm going to deal with for the rest of my life. Remember that sometimes people act out and they're jerks when they're trying to compensate or trying to mask other things they have going on in your life. So if you know someone, reach out to a friend. Just make sure you talk to your friends. Make sure they're doing okay. You know, if you guys are having issues, reach out to someone yourself, okay? Pick up the phone, talk to someone. Don't let it get you to a dark place. Don't let your friends go to the dark place either, okay? Remember, communication and kindness. One of the biggest things that I feel like we're lacking in these days is communication and kindness. People don't talk about themselves, their feelings, their emotions enough. People don't act accordingly. People are rude. People get stuck in traffic. You know, I told the story a few times in the last different videos, but I still can't forget the day that I was so frustrated while I was sitting in traffic, and I was just aggravated because it caused me 45 minutes. And then I realized that the traffic that I was sitting in was because they were honoring a fallen soldier that had died in Afghanistan. One of the, I believe, 13 soldiers, and he was being flown home, but unfortunately he was being flown home in a casket. Right. And they shut down the freeway, and there was a procession down the freeway, and I couldn't help but feel like the biggest jerk in my stomach when I saw what was going on. Okay. So sometimes we have to understand that there's reasons things are happening. We're a little inconvenienced, but that family didn't get to bring their son home, their brother home alive. Right. So it's so important to slow down and remember that, you know, everybody's going through something, and while it doesn't necessarily justify their actions, remember that, okay? Maybe they just need a helping hand. Maybe they just need a kind word. I can't thank you guys enough. You are amazing. Thank you for giving me this platform to be able to ramble on, okay? I am so humbled, and if you guys have any comments, leave them down in the YouTube comments. Feel free to send me an email to hvacrvideos@gmail.com if there's anything you want to talk to me about. I try to communicate back with everybody as much as possible. So thank you so very much, and we will catch you on the next one, okay?